Hello everyone. So today we're going to do a question from 30-day LeetCoding challenge, and the question asks us about leftmost column with at least a one. And when I first read this question, I was like a little bit confused, like on what we're supposed to do. But after like reading like this question like a couple of times, I kind of understand the question, and also like the example. It's help us like to understand the question as well. So let's go ahead and read the question together. So this problem is an interactive problem. What they mean is basically we need to use their wrapper or their class in order to access the data. And okay, second line, a binary matrix means that all elements are either 0 or 1. For each individual row of the matrix, this row is sorted in non-descending order. In non-decreasing order. So basically it's saying that in each row, the number will start from small to uh, bigger and increase bigger. So, and next, given a row sorted binary matrix, return leftmost column index with at least a 1 in it. If such index doesn't exist, return a -1. So like here is like a little bit tricky. So what they want us to do right here is they want us to return the columns, the the index column that contain a 1. And if not, if the whole matrix contain only like 0, we're supposed to return -1. So for example, right here, if the whole matrix doesn't have any 1, we just return -1. And the reason that they return 0 right here, because this column 0 containing 1, that's why we return here, return index 0. And for this one, so the leftmost column that contain 1 is column 1. That's why we return column 1. If you look at the index 0, like index column 0, there is not any 1. That's why we cannot return this column. This column contains 1 as well, but it's not like the leftmost. That's why we return this column as the leftmost. And this is like the function that we are allowed to use in this problem. So binary matrix get x and y, so you need to provide like a row and columns, and it will return you the value of that element in that index. And this is just like give you the dimension. And we don't want to call this function more than like 1,000 times. The reason it's 1,000 times is because if you look at the range of the matrix, so the row is the length of the row is between 1 and 100, and the length of the column. So this is the column. So the length of the column is also between 1 and 100. So if we call like 1,000 times, it basically means that you traverse through like the whole matrix to do that. Because it's 100 by 100 is like the maximum size that this problem can have. And ij either 0 or 1, so it's basically mean that this matrix is a binary matrix because it can only contain 0 or 1 at 1. And it's saying that each row is sorted with an increasing order. Alright, and as you can see right here, what we got is we only got the, the the class of here, so we cannot access the array. We need to call this function to access the array. So in order like to solve this problem, we should look at the example. So I'm going like to write this down onto a paper, and like we can look into it a little bit more. So let me close this. Alright, so if you look at this example, So we want to return this column, right? Because this column contains 1, and it is like the leftmost column. This is not the leftmost column, and this column contains 1 as well, but it's not the leftmost column. That's why we return this one. So the other way to think about this problem is we want to find uh, we want to find 1 basically. So we want to find 1, and we want to find 1 at the leftmost column. So what we can do is we can like think about this row. So we take that rows out. So that row is 0, 0, 0, 1. And according to the question, we know that this row is sorted in an increasing order. So we know that if we have seen 0, it means everything to the left of it have to be 0. Or just like this one. If we see 0 right here, it means everything on the left of this it has to be 0. And for this one, if we see 1, uh, it can go either way. Like on the left side of 1, we can have 1, and on the right side of 1, we can have 1 as well. Let me give you like that example. So for example, if we have like all 1, so as you can see, this is still following the criteria of the question, because the row is sorted in an increasing order. As you can see, 1, 1, 1. So to the left of this one, you have 1. To the right of this one, you have 1. So when they tell us that we cannot uh, do this problem in like n square, so they said that we cannot call that function 1,000 times. Basically, it means it's n by m, and we know that the maximum of n and m is 100. That's why you got that 1,000. So we can say that this is like n squared. So the other way we can think about this problem is, can we solve this problem in n log n? Or can we solve it in n? So like to solve this problem in n, I don't think it's possible. And the reason that it's not possible is we can check like one column, right? And if we see that column, so let's say that we check this column, like this first column, and we didn't like find 1, so we cannot stop there. We need to go to the second column, right? So n is not the baseline for this problem, because like this, like to check each column, we require like n time already, right? So the next best thing that we can do is n log n right here. So when we think about something log n, we either think about like a binary tree, or binary search tree, or like maybe binary search. Because log n that's like the time complexity for binary search. So what we can do is we can like traverse through this matrix like row by row, and then we try to find the column of 1 in each row. So like for this example, we find 1 in the 0, 1, 2, 3 in index 3 column index. We count from 0, 1, 2, 3. That's how I got 3 here. And for this one, the leftmost column is at index 2, and this is the leftmost column is on index 1. So if you think about time complexity, if we go through like each row, it will take like n time. And like to search through it, since this is a sorted array, we can use like a binary tree, no, binary search to search. Uh, so it means that on each row we require log n. So it's n log n. That's what we want. It's less than n squared, and it should give us the result. So in order to do that, we can like create a function called define find one. So find one here will take low. We'll take so what will it take? So we'll take the row of each row. So we know that. So we look at just like a single row. Let's say the last row, right? So what we want to do is we want to return this index, right? So we can do like binary search. So binary search is we need to have low, which is equal to 0, high. I think we need a high in here. So high is equal to high, and then we can say that while low is less than high. So this is basically equal to high. So this is basically just a binary search tree, and then binary search mid is equal to low plus high divided by 2. So we go to the middle and we check. So if the middle is 1, so we're going to use the function that they provide us. So that function is so if binary matrix. So we need to provide dot get, and for dot get we need to provide x and y. So x would be the row, and y would be the column. So let's be mid. So if this is equal to 1, I think we also need another variable to keep the current column. So let's say current is equal to -1. So we initialize to -1 because that's the value that not in the range of the answer. So we can initialize to -1. So if this is true, we want to update our current to be equal to mid. And also we want to move. So initially our low here, high is here, and mid is here. However, there is a chance that we might have 1 on the left side. Yes, but right now we are on mid right here, and we found it's 1, right? But there's a chance that this might be a 1 too. So let's say if it was a 1. So that's why we want to change our high is equal to mid -1. Else, so in the case that we don't find, so in the case this one, we have low and we have high like here. And in the case that we cannot find 1 right here, we want to change our low to here. So low is equal to mid +1. And right here, we can just return current. And for our high level function, so this is like the function that will be called by the main function. So the main function, let's say leftmost common with 1, right? And this one's take the binary matrix, right? So in here, we want to initialize our want to initialize our current to -1, and then we want to find the dimension. So row and columns. Row is basically, so there's a function that allows us to find that. So it's called dimension. So we just call the binary matrix, then dimension. And then for row, we want to take the 0 index. And this is the same, except that we want 1 index. And then we can like go through the row, so we can do uh, for I in range of row, and then we want to call, and then we want to store the value of this function. We can call it find1, and then we need to provide the row. So row is I, and high is the column. And if temp is not -1, so if you find something, so if temp is not -1, I think we should initialize this to infinity, so it would be, float, float right here, and temp is less than current. Want to update our current to temp, and right here we want to return temp. So yeah, let's walk through like some example to see if this code works. So let's say this example, right? So for this example, we will have like 3 rows, so we will traverse through the loop like 3 times, and for this one, it goes to the first row right here. So when we look at the first row, so we pass C here is the high, so it's should be 4. Yeah, so that's the issue. So we want to do like C minus 1 right here. Yeah, so it should be good. And then right here, it starts with 0 and 3, right? And then it go to 3 divided by 2, we should get 1, so it go right here. So since the value is 0, so since the value is not equal to 1, it's going to move the low to mid plus 1, so low right here and high right here. And then the new mid would be, so the new mid would be 2 plus 3, which is 5. 5 divided by 2, we will get 2. And then this value is 0, right? So our mid is 0. And then we want to move our low to here. When we move our low to that place, we see 1, right? So since we see 1, we want to update our current to mid. So our mid right now, our mid right now is 3. So we will return 3 right here. And then it's also change this value, like change the value of high to left, so it will like break out of this loop. So yeah, the solution looks good, and I'm going to show you the code that I wrote like on the in the terminal. I mean on the LeetCode website. So let me. All right. So like this is the code. I think it's slightly different, but it should be just similar. I run this code, I have some debugging print. And 0 and 0, let's submit it. So this code should be working. Yes, I did. Alright, thank you very much everyone for watching. I hope you guys are doing fine during this pandemic. And stay safe. Take care. Bye bye.